Hello, hello. Hello, hello.
Good evening,
I'm
sir.
audible. Good evening, everyone.
Good evening, sir.
Good evening.
Good evening, Atul. Good evening, Atul.
Hello, hello. Good evening.
Good evening, sir.
Good evening, sir.
आप दिख नहीं रहे आज ही
दिख नहीं रहे? ये ऑरेंज. हेलो.
गुड इवनिंग सर
इसको मैं दिख नहीं रहा हूँ.
Good evening, sir.
अच्छा हाँ जी
Good afternoon, sir.
Good afternoon.
Morning, sir.
Good afternoon, sir.
Good afternoon. Okay, screen is visible.
Yes, sir.
Yes, sir.
नहीं, दोबारा गई. Just hold on. Okay, fine.
Yes, sir.
Yes, sir.
गुड इवनिंग सर सर कल के रिगार्डिंग मुझे एक क्वेश्चन
हाँ हाँ, tell me.
सर जैसे कि हम कोर और डिस्ट्रीब्यूशन लेयर की बात करते हैं
हाँ,
तो
आगे.
डिस्ट्रीब्यूशन लेयर के जितने भी हाँ डिवाइसेस हैं वो डिस्ट्रीब्यूशन लेयर सर इफ सपोज एक पाथ अगर डाउन हो जाता है तो ट्रैफिक विल कम फ्रॉम डिफरेंट पाथ अगर वही पाथ जो ट्रैफिक जो डिस्टॉर्ट हुआ था पाथ वो रिस्टोर हो जाता है तो अब ट्रैफिक कैसे फॉलो करेगा मतलब कैसे जाएगा
Traffic will come back to the primary link.
सर ऑटोमेटिकली या कुछ और कॉन्फ़िगरेशन करनी पड़ेगी
कुछ नहीं है. Like it will automatically come.
ओके
सर एक
STP चलता है ना. STP. I hope you remember, right? STP and all.
यस सर एसटीपी यस
So when we are talking about switching, if any port is not working because it is blocked with STP, and when a primary connection goes down, automatically the block port will become active.
ओके सर ब्लॉक एक्टिव हो जाएगा जो प्राइमरी लिंक हमारा कटा है उस पे तो अब एसटीपी बनेगा ही नहीं दोनों लिंकों पे तो फिर सर जब कट गया तो दूसरे बैकअप पाथ ऑन हो गया तो उसके लिए तो एसटीपी के लिए उस दोनों डिवाइसेस के लिए एसटीपी ऑन ही नहीं हुआ फिर जैसे ही बैकअप पाथ प्राइमरी पाथ अप आया तो प्राइमरी पाथ पे ब्लॉकेज कर देगा वो
Do one thing, create a topology in spanning tree protocol. Okay.
Okay, sir.
Sorry, in packet tracer. Okay. And try to check, just put one computer on in the last in access layer and just add one computer in the core layer. Okay, so there are 3 layers, na? Core, distribution, access. So attach one computer to the core layer, attach one computer in the access layer,
Sure.
try to ping, make one port inactive and check how the traffic is flowing. Okay. So yesterday video was actually, I don't know why we have not uploaded, but it was YouTube live also. So I just added a link. Okay, so what we'll be going to do today, we will be learning today packet switching and forwarding. Okay, so this is chapter 2, packet switching and forwarding. Okay, so this was the day 1. So that was chapter 1. Okay, that chapter name was Enterprise Network Architecture. So today we'll be discussing about this one. Okay, so let me change this to a card. Okay, so packet switching and forwarding. So what we are going to learn. So first of all, today it's more of theory topic, guys. Okay, but it is very, very important because you will understand the inside view of the device. Okay, मतलब आपको ये पता चलने वाला है आज कि डिवाइसेस के अंदर कितने तरह की मेमोरी ओके कितने तरह का स्विचिंग ओके बेसिकली व्हाट वी आर गोइंग टू अंडरस्टैंड द आर्किटेक्चर and we will be going to discuss about fib architecture. So we'll be talking about these topics. Okay, so architecture, then difference between hardware and switching, software switching mechanism, MAC address table and TCAM. Okay, and also we'll be discussing about fib and rib. Okay. Sir, date is showing 25 May. Sir, I have doubt regarding layer 3 architecture. In which scenario we prefer L3 switch directly connected with ISP? Is it safe to do? So normally we connect router. Okay, so if you see this design, so obviously you need a router. You will not connect ISP directly to the multi-layer, but it is completely your choice if you want to add the ISP here. Okay, and also if you are getting the connection directly from ISP, you can have a firewall also. Okay, you can have a firewall in your company. Before a switch, you can place a firewall so that ISP is giving you connection, right? So you can have a firewall and then you can add in a link in the multi-layer switch. रिकॉर्डिंग तो लगा लीजिए सर जी. ठीक है सचिन जी, थैंक यू बताने के लिए. बिकॉज कुछ लोग तो क्लास में आते ही इसलिए कि बस ये देखें कि क्लास ऑन है नहीं, रिकॉर्डिंग है नहीं. Okay, so hi everyone. So we'll be learning today chapter 2, that is packet switching and forwarding. Okay. Okay, so let's start. So let's learn the full forms first. Okay, so there is a term called fib. Fib stand for forwarding information base. Okay, so repeat with me, forwarding information base. Okay. Then we have a routing information base, that is RIB. Okay, let's learn the vocabulary today. Okay, so the RIB stand for routing information base. Repeat with me, routing information base. FIB stand for forwarding information base. So what are these? We will be going to discuss. Okay. Then there is a term called CAM table. Okay. Not that Punjabi word CAM. Okay. It's an English word CAM. So CAM is content addressable memory. Okay. So this means MAC address table basically. Okay. So the CAM table is also called MAC address table. And then there is a term called a ternary content addressable memory. So that is ternary content addressable memory. Okay. And then we have one amazing technology from Cisco, that is Cisco Express Forwarding. Okay. And there are other techniques which are hardware redundancy. So these are like switching mechanism. Okay. So like fib, rib, they both are fib and rib. If you ask me what are these, so they are routing information bases. Okay. So they are related to routing. Okay. So let's write here related to routing. Okay. Then we have two CAM and ternary content addressable memory. So they are two types of memory tables used in switching. Okay. So these are, देखो मुझे notes बनाने में भी, yeah. So two types of memory table used in switching, that is content addressable memory. Okay. And then ternary content addressable memory. So we have two type of routing information base or tables, you can say. And by the way, if you don't know, RIB is your routing table. Okay. So your routing table is called routing information base. Okay. Normally when we learn CCNA and all, we call okay routing table, but routing table, there is a technical word that is called routing information base. Okay, router के routing table को ही RIB बोलते हैं. Okay, routing table has a different name also, that is called RIB. And then we have switch hardware redundancy mechanism, which we'll be talking about. And this is also switching, and we'll be talking about 3 types of switching mechanism. So let me write down here switching mechanisms. Okay. So first one is process switching. Process switching. Then we have a fast switching. And the most fast switching is CEF, which is Cisco Express Forwarding. Okay. So 3 types of switching mechanism. Okay. So ये हमारे 3 टाइप के switching mechanism है. Okay, so the most important CEF, because Cisco, so the related to routing, these are the tables, fib and rib. Okay, then we have 2 type of memory tables, which are CAM and TCAM. And then we have switching mechanism, process switching, fast switching, and the Cisco Express Forwarding. And then we have the switch hardware redundancy mechanisms. Okay, so these are stateful switchover, non-stop forwarding, and there is a term called, yeah. So the first one is switch SSO, and then we have NSF. Okay, so it's not complex, just make sure you understand these are just a few technical vocabulary. Okay, do not think too much right now. We will learn these things. Okay, and there is another template mechanism to allocate. There is another thing that is called SDM templates, switching device manager templates. Okay. So yesterday, what we have done, like if you remember, like we have discussed the layer 3 architecture, we have core layer, distribution layer, access layer, right? And in some companies, 3-layer architecture is there. And in some companies, 2-layer architecture is there. So if you have a big company, you should have a core layer so that you can manage the devices very well. But if you do not have a core layer, then you have to connect all the distribution devices together, right? So nowadays, the latest switches like 9400 series, 93, 9200 switches are there in the market. And according to your company design, you can buy access and distribution and core layer. So this is a new design model 9606, which is a chassis model where you have 2 supervisor engines. Supervisor means brain. So also like you can add multiple ports, and this device has multiple power options as well. In case if power fails, the device will be active. So this is the example, like you have a core layer, you have access switches. Okay, so here we do not have distribution. So the top device, we can call this core also. And this core layer is connected to data center, WAN, internet. Okay, and the switches are connected to access point to give the connection in wireless form. And switches are also connected with the cables where you are getting the wired connections. Okay, so this is a good example of 3-layer architecture in a company where you have multiple access devices, and these all devices then going in the distribution, and then the all distribution devices are going in the core layer, and core layer is further connected to internet, WAN, MPLS, or maybe data center. Okay, so in real world, like depends on scenario to scenario. Sometimes we use a distribution layer, like we do layer 3 routing, like maybe we are running OSPF between 4 devices, and in the lower section we are using the normal spanning tree layer 2. Okay, and layer 2 is going to block the ports, right? And in some companies, if what is the benefit here? If we use proper layer 3 till distribution, core, and access, we do not have to block any port because all the links are layer 3. Okay, so there are some benefits also, and there are some cons also. Okay, so there is a technology called Stackwise where we can combine the devices together, and there is a technology called Ether channel where we can combine the ports and get high bandwidth link. Like if you have 1 GB, 1 GB, you can combine the link that is called Ether channel. So when you combine the links together, that is Ether channel. And then what is this Stackwise? Stackwise means you connect multiple devices together and they will behave like one switch. Okay, they will behave like one switch. You do not have to configure 4 devices separately. ये सारे switch एक ही हो जाएंगे. Okay, all switches will become one switch. Okay, that only if you use this cable, that is backplane cable. Okay, so this cable has a special name, backplane cable, and this technology normally we have in Cisco devices. This is a Cisco proprietary technology, Cisco stacking. So benefit is that we do not have to log in multiple devices. Just with one telnet, you will have the control of all 4 devices. Okay, so we have different designs in the market. Like we have layer 2, layer 3 mechanism. So just check the yesterday video for that. And we discussed a little bit of SDXS. What is overlay? Like the over top view is called overlay, but the actual networking, what is and how all devices are connected, that is called underlay. So nowadays, like in data center, we have this technology called spine and leaf, where the core devices are called spine and the small devices are called leaf. Okay, so this is what we have done, and rest you guys can check. Okay, so today we are talking about packet switching, as I mentioned. Amit, we'll discuss fabric capacity planning, something. I don't know in which context you are asking. Okay, and so already I think most of you don't know these topics, right? So let's learn these topics rather than you giving me new content to teach. Already have enough data today to discuss. So what? So layer 2 switch operation. Okay. So what we'll be discussing? Let's see. Okay, so consider this is a design of a switch. Okay, so what is this design? That whenever a packet comes, so consider this is a switch. Okay, so ये समझो एक switch है, and what whenever a traffic comes from the port, which is called ingress queue. Ingress means when a port is coming inside the device. Guys, stick in to the class till the end, okay? Then you can have questions. If you are leaving early before the class, then I'm not responsible for all your queries, because we discuss a lot of doubts after the classes. Okay, so if you have any question, just pen it down somewhere and we'll discuss. Okay, so consider this is a switch, and so whenever a traffic is coming here, so there are 3 things. One is called CAM table, which is MAC address table, which is used for layer 2 forwarding. So whenever a device, suppose a laptop, whenever a computer, say computer A, I want to go to computer B on the right side. So whenever a computer A forward traffic, that is going to hit on the ingress queue. Ingress means any traffic when comes from any port, that is called ingress queue, because queue means like if you are getting a lot of packets, so there is a queue. So the first to come first packets will be prioritized, means processed. Okay, so all the packets are going inside this. So that's layer 2 forwarding table, and the same copy will be going in the security ACLs. Okay, so basically TCAM is used to check the ACLs. If you configure any ACL like access control list, Okay, if you have any security, then it will be checked here. And also if you have any quality of service ACLs, that is also checked in the quality of service ACLs. So basically TCAM is like a copy of your MAC address table where we will check the security ACLs, quality of service ACLs. So whatever you configure in the device, all will be checked and then it will be processed and sent out from egress. Egress means outside port, traffic leaves a switch port and traffic arrives at switch port. So whenever a packet comes inside a switch, okay, the switch frame will be forwarded to all these things. So when the switch select a frame from the queue, so it needs to answer a few questions like how I'm going to forward the frame, where should I forward the frame, and should I even forward the frame, right? So there are some tables which I will be going to show you, MAC address table. Okay, and before I say the layer 2 forwarding table, जो सबसे पहले table है, the first table, layer 2 forwarding table. So where all the MAC address will be indexes. Means if any device forward any traffic, that will be going in the CAM table or MAC address table. Okay, if the MAC address is found in the MAC address table, the frame is forwarding to the MAC port. Okay, so we'll do a small practical on that. Okay, and ACLs and quality of service. Then we have two other. एक ACL वाला होता है. We have ACL table where we check if we have any ACL. ACL means access control list. If you have any security, so if it is blocking any device or not, okay, a single lookup is decided. So basically we check if we have blocked the port, we have blocked the IP address and all. So that we check in the ACLs. Also we check in the quality of service. So when we implement quality of service, okay, we also check if any traffic is prioritized or rate limited. Rate limited means if you do not want to forward a lot of traffic, you want to just send 50% of the traffic. Okay, so quality of service means that which traffic you want to prioritize, which traffic you do not want to prioritize, all these things. So when it comes to these table, okay, which I was discussing here, okay, CAM and TCAM. TCAM is ternary content addressable memory. Okay, so these are the things, not this one. Yeah. So Cisco switch maintain CAM and TCAM tables. So दो तरह के table हैं. The CAM is used in layer 2 switching. Remember, this is called MAC address table also. And TCAM is used in the layer 3 switching. Okay, TCAM is used in layer 3 switching. This is why it is also used to check like ACL, quality of service and all. Okay, because we confirm a lot of other things from these tables as well. Okay. Okay, let me show you the diagram. So that was a design of layer 2 switch operation. Okay, where you can see only layer 2 forwarding table CAM and TCAMs are there. Okay, but normally TCAMs we use in layer 3 also. Okay, and if I show you the other design. Okay. Yeah, Pramod, just hold on. Okay, so you can see here there is a fib table, which is forwarding table, fib, and there is a CAM table. Okay, so whenever a packet is coming on the port, we check the CAM table, then we check security ACL, quality of service, all other things. Okay, and here we also check the layer 3 forwarding table. And by the way, right, so you can see here only we are checking the CAM table here. This is why there is a chart here that we are checking MAC address, from which port I want to forward the traffic, and there is a VLAN. okay, in which VLAN I want to forward the traffic. But if you see the layer 3 operation, we also check the fib table, which is like a combination of routing table and cache memory. Okay, we'll discuss in further way, where we check, okay, where we want to forward the packet, what is my next hop IP, what is my next hop MAC address, and these next hop MAC address is all. Then we check the CAM table. Okay, so a lot of things we check. Okay, it means whenever we forward the information in the format of layer 2, we check the CAM table. तो जब भी हम layer 3 की बात करते हैं, whenever we talk about layer 3 mechanism, here we say this is layer 3. Okay, let me write down here. देखो ये टॉपिक थोड़ा टफ है, एकदम से नहीं समझ आएगा गाइज, और ये वैसे भी कोई पढ़ाता नहीं है, देख लो जाके कहीं वीडियोस भी, मुश्किल है. So normally we start from VLAN. Okay, any batch of CCNP ENCOR, we normally people start from VLAN topic. Okay, so I'm just helping you to understand the basics. Even if you understand this topic 30-40%, still it is good. Okay, I'm not expecting that you understand 100% of these things, because this is hardware architecture of a Cisco, and we need to go very deep dive inside the technology. Okay, because all these are technologies made by Cisco, so that you understand what is the mechanism, how the device is forwarding packets. So this is layer 2 operation. I told you layer 2 forwarding, MAC address will be checked and all. And in the layer 3, like layer 2 forwarding, again the similar way, in the multi-layer, we check MAC address and all. Then we check to forward layer 3, we check our fib table. Okay, to forward the layer 3 information, we check the fib table. Okay, so fib table is like your routing table, you can say. But we check other things also. What is next hop address? What is next hop MAC address? Okay, so ये सब चीजें रहती हैं. And again in the layer 3 also, we check ACLs and quality of service. So what do you see here? That I have given a difference here. That layer 2 switch operation, we only check, okay, layer 2 forwarding table. And if there is any ACL related to layer 2, because ACL is not only layer 3, we have layer 2 ACLs also. Okay, that is called MACLs, MAC address access list. Okay, so we can implement quality of service also related to layer 2 also. So in layer 3, we check layer 2 forwarding table, which is like we check the MAC address. Layer 3 forwarding table, we check the fib table, forwarding information base, and we check next hop address, next hop MAC address, all these things. And then we have quality of service also, where we check the same way, that which traffic is prioritized, which traffic is not prioritized. Okay. I have already shared the notes yesterday also after the class. So please stick in the class, we'll share. Sir, this is the CAM and switch which over. Okay. The CAM table, you can say it is layer 2, na? MAC address. So TCAM depends. Okay, if it is processing layer 3, you can say layer 3. Okay, so let's talk about control plane and data plane. And if you understand this control plane, data plane, then it will be easy for us to understand the fib, rib, all those things what we discussed. Okay, so in network device, okay, we have 3 types of traffic. Okay, a network device has 3 types of traffic. Can anybody tell me? So the first traffic is called management plane, where we do telnet, access list, telnet, SSH and all. Then we have control plane, where we manage all the routing protocols. And then we have the forwarding plane. So we have 3 types of traffic inside my device. Sorry. Control plane, management plane, and forwarding plane. Okay. So whenever we forward any traffic like routing protocol, packets exchange, that will be all done with the control plane. Okay. Whenever my data packets are going further, that is all done with the forwarding table. So there is a picture which I will show you. Okay. So you can see here. So whenever any routing protocol like OSPF, EAGRP, if they are sending packets to each other, suppose hello. So router send hello packets to each other, yes or no, in EAGRP or any other protocol. So when they are saying hello to each other, so that is a message of route OSPF or EAGRP. So whenever routers share any packets related to routing protocol, okay, and when they send update packet, when they get a network from all the routers to each other, right? What is routing protocol? If anybody do not know what is routing protocol, forwarding of packets from one network to another network. Okay. So you can also say language between routers, how routers are going to share information with each other. That is all done with the routing protocol. So your routing protocol like EAGRP, OSPF, okay, all these protocol work under the control plane. Okay. And they make a table that is called routing table. So even your routing table is under the control plane. Okay. Then we create a table that is called, this is called RIB and this is called FIB, forwarding information base. Okay. The full form is forwarding information base. Okay. And this is called routing information base. So packets. So consider if routing protocol wants to discuss anything from a router. So router is forwarding the packet from the control plane and forwarding to the router. Okay. So all your OSPF packets, all your EAGRP packets will be going off from the control plane. Okay. So when it comes to the incoming packet, like suppose you are going to google.com. So consider this is a router. Ye router samjho. So now this is a computer where there is a switch going to router, then there is a maybe internet connection. Okay. So whenever a laptop say I want to go to google.com, traffic goes to switch forward to the router, and then router check routing table where I want to forward the packet. Okay. But if already you are going to google.com or maybe to internet every time, so like when the computer say I want to go to internet, automatically like a router will shift your traffic to the data plane. And in the forwarding table, already we have mentioned that okay, to go to google.com, I have to forward my traffic from FA01 interface. Means I do not have to. So control plane is like a brain of a router. Okay, so this is like a brain. So whenever your LAN users are saying that I want to go to google.com, Facebook or gmail.com, so router is not going to use his brain every time because already router has given you the information, okay, to go to internet, go to FA01 port, right? So router दिमाग नहीं लगाएगा, हाँ, okay, for the first time, for the first lookup, when for the first time you say I want to go to google.com, router will check routing table. He will see, okay, I have a default route which I am getting from this ISP from internet and the exit interface is FA01. For the first time we check the routing table. From now onwards, all my traffic is going to go with the data plane. Okay, मतलब मेरी सारी traffic, all my traffic on my router is forwarding from the data plane. But for if I do not have the cache, this is like a cache memory. Okay, so if you do not have any cache memory, you forward to the control plane. Control plane will check routing protocol, routing table, then check everything. Then it will forward the traffic to the devices. So basically, the control plane takes time, but data plane do forward the traffic very fast. Okay, so this is called control and data plane. अभी और देखेंगे इसके बारे में. Okay, we'll discuss more. But as a like whenever you learn network automation, so the first thing we teach every student that in a computer, in a router, in a network devices, we have control plane and data plane. These are the more important ones. There is a management plane which is used for telnet SSH. Control plane control the device. It is like running the routing protocols, sharing lot of important protocols or information. But when everything is set, control plane create a cache memory, and that cache memory is called data plane. So this routing table is called RIB, and the data plane table, which is called forwarding table, is called fib. That was the topic here. So fib matlab kya hai? The fib table is in which memory? Tell me guys in the chat. Data plane. Okay, and where you have this RIB, this is made from the control plane. देखो पहले दो टॉपिक समझ आए थोड़े थोड़े अब. Yes, you got the point. So this is the pattern. Okay, so when you see the content, does not mean that you understand everything in one go. Slowly you understand the topics, and we go back and see the chapter, and then you get confidence. Okay, there is a pattern to learn. If you just looking at the content in CCNP book and just randomly asking questions, there is a way to teach and there is a way to learn. I hope you understand, right? सब कुछ बुक से हो जाता तो टीचर ही क्यों होते? Yeah. Okay, so we will be talking about now. Okay, the switching mechanisms. यस सेफ पढ़ रहे हैं अभी. सेफ पे मिस नहीं करा मैंने, डोंट वरी. ये तीनों चीजें पढ़ेंगे ना अभी. पहले लाइक विल डिस्कस प्रोसेस स्विचिंग, फास्ट स्विचिंग. ओके, forwarding plane is a data plane only, na? Forwarding plane is not any plane, right? Data plane is called forwarding plane also, you can say. Okay, forwarding table is called fib. मैंने कब बोला यार? When did I said control plane is a data plane? Control plane is a different plane. Data plane is a different plane. Control plane, where it is like a brain of a router, where it all routing protocol work on the control plane, and they build a routing table. With the combination of routing table, router creates a cache memory, and that cache memory is called forwarding table. That is also known as fib, forwarding information base. Clear? हिंदी में अनुवाद करूं? जो राउटर आपस में बात कर रहा है उसे कंट्रोल प्लेन कहते हैं, और राउटर जो आपकी ट्रैफिक बाहर भेजता है उसे डेटा प्लेन कहते हैं. खत्म. ओके, सो नाउ आई नो दिस इज लिटिल मोर फॉर यू टू अंडरस्टैंड. ये इतना थ्योरी तुमने शायद पता नहीं कब पढ़ा था, बट इट्स इंपॉर्टेंट. ओके, so we have to read line by line because that's very important. Okay, so first of all, there are three switching mechanism. So one is called process switching, fast switching, and Ceph. Okay, So सबसे पहले कौन सी पढ़ रहे हैं हम? फर्स्ट वी आर लर्निंग द प्रोसेस स्विचिंग. कॉपी नहीं हो रहा इधर. या how to make this yeah. Okay, so in the process switching, so what is process switching? In this switching method, router strip off the layer 2 header for each incoming frame. So it means whenever a router receives a packet, router is, let's take an example. Suppose this is a router. So whenever any packet comes to router, okay, from any device or anywhere, so we forward router which information? Packets, right? But we do not only forward packet, we always send signals to the router, whether we are sending from the switch, whether we are sending from the router. We are all send signals on the cables, right? Not packets. If you cut a wire, do you see packets? No. That's signals, transmission, okay? Whatever you want to say, signals, okay? So basically, router get 0 ones, and from the TCP IP or OSI model, this all 0 1 work on which layer? Physical layer. So with the help of physical layer, router is going to build which table? Router is going to check the layer 2, means router is going to check the MAC address, right? So that is called layer 2 header. So this MAC address information we have here is called layer 2. The layer physical is called layer 1. And then on the top, we have layer 3 information that is called IP address information. That's layer 3. Yes. So now read, in this switching method, router strip off layer 2 header, means router is going to remove the MAC address information. Okay. And it is going to check the layer 3 because router checks routing table. Router is going to check where I want to forward the packet from the IP address. Look up the layer 3 destination address in the which table? In the routing table for each packet. So it means if you send 100 packets, router is going to do this for 100 times. Are you getting my point, Alfred, Simon, Krishna? Okay. And then send the frame with the rewritten layer 2 header, including CRC. CRC basically is used to check if there is any error in the packet or not. Okay. Cyclic redundancy check during the transmission that my device got any error or not. Okay. To the outgoing interface. Okay. So, and send the frame with the rewritten layer 2 header, including computed cyclic redundancy check to the outgoing interface. So means, can you see all this happening in the router? Okay, that every packet we send on a router check layer 2, remove that information, then check the layer 3 information, then forward the packet again, it adds the layer 2 information. Okay, so first remove layer 2, then check layer 3, check routing table, then again check add layer 2, and then again forward the packet to the outgoing interface. And you say that you are the only person who has pressure. So you see this man router. He is carrying a lot of pressure on him. खाली तुम पे प्रेशर नहीं है भाई, राउटर पे भी बहुत है. Right? So all this is happening, and this is called process switching. That we are doing everything in the device. We are checking the layer 2 information, we are checking layer 3, then we are checking the routing table, then we check, we do the cyclic redundancy check for our hardware, if my packet has any error or not. Krishna, it is stripping off the layer 2 header because router checks routing table, and in routing table we have IP address. Okay. So to check the IP address, we have to remove the layer 2 header. Then only router will go deep dive and check the layer 3 information. Okay. So understand, we first get 0 ones, we make a frame. And when we remove the frame layer 2 information, then we check the packet. And when we remove the packet, then we check the segment, which has a port number. Remember your OSI model concept. Okay, so this is why this process switching is the most CPU intensive method available in all Cisco routers, and it greatly degrades performance. Can you read this line? It greatly degrades performance and is generally used only as a last resort or during troubleshooting. So normally the device is like is going to be very CPU intensive if we will keep this method. But nowadays we have very good advanced devices, so that you do not require that CPU intensive. Okay, you can read here again. In this switching method, router strip off the layer 2 header, then it checks the layer 3 information in the routing table. Second point, then it again send the frame again with that layer 2 information, right? Then again we check the CRC to check if any error, and then we forward that information to the outgoing interface. And this all work is highly CPU intensive, and this greatly degrades the performance in the Cisco devices. That's why, let me show you a diagram. You will understand more. So see this picture, there is a control plane, right? Control plane means all my device's brain is called control plane, and data plane where we forward. First packet comes on the interface. It is going to the control plane, eating the CPU and memory, and then forwarding to the outgoing interface. Yes or no? Now the second packet comes. The second packet again go to CPU, eat RAM, CPU, and also processing the exited, go to a outgoing. Means all packets, can you see all packets one by one is going to the CPU? This mechanism is called process switching. Is that clear? All packets will hit CPU. All packets will take CPU intensive. So, and going from the egress interface. So it is not the best switching method. Okay. Then we have fast switching. Devashish, because Devashish is asking why router has to add layer 2. Okay, tell me if you understand. I think your basics. Yeah. अच्छा एक बात बताओ मुझे. So whenever a computer, okay, or laptop forward a packet to switch forward to multi-layer switch or router, whatever device. Okay, then we forward to another switch and then maybe to another laptop. Right? I'm sure you have done this lab. Right? Router connect with two different networks. So whenever a computer A forward packet to computer B, so we forward packet to switch will broadcast, it will forward to router. Then router is actually receiving what signals? Router will check 0 ones, and then it checks the MAC address, and router will accept the frame because computer is putting his gateway MAC address in the packet. Because when the computer forward a packet, computer has a MAC address like AA, suppose, and the MAC address of router B is BB, example, okay? And there is another interface of a router which is CC, and D kind of. And then maybe we have a computer B which is D something. So what will happen? First source MAC address will be this, destination will be this. So now router check the packet, check the MAC address. Okay, this is for me. Router will accept the packet. Then it will open the packet, check the IP address. You want to forward to 2.2.2. Okay, fine. Got the information. Then I will again add the MAC address. Now source will be this, destination will be this. So it means when I forward the packet from incoming and forwarding the packet going outgoing interface, I will also change the MAC address. Yes or no? So that I will forward the packet to the computer B. If I do not have the MAC address, what I will do? Tell me. अगर मेरे पास कंप्यूटर बी का मैक एड्रेस नहीं है, if I do not have computer B MAC address, router is also going to add what? FFFF. Yeah. Broadcast. लवदीप डिफॉल्ट रूट पे पहुंच जा तू सीधा. I'm giving an example of do one thing, just do that lab and try to check what is going on the device. Fast switching, you will understand by looking at diagram only. Okay, you will just understand by looking at the diagram. Okay, first let me show you process switching again. All packets going to CPU. Yes, Mahesh, clear? All packets going to control plane. All packets going to control plane. Yeah, Keshav, that is old one. Just I'm teaching you from the latest content. Just to forget store and forward all that old designs. Okay, so what is fast forward? The only first packet is going to control plane. We get the details, we store that in the cache memory. And now from the second packet onwards, we are forwarding the information to outgoing interface. And that switching is called fast switching cache. Because by looking at the CPU, by looking at the routing table, we already know that I have to forward my all this kind of similar traffic to this outgoing interface FA01. So that's why the fast switching, only first packet will be checked, and then we check similar type of packets. Then we create a cache memory, and further onwards, we will be forwarding the packets. Okay, it means, so the switching method is faster than process switching, yes or no? Because we are not forwarding all packets to CPU. So with the fast switching, the initial packet will go to process switching. The first packet will do the similar process switching. And further on, it will be examined by CPU. It will check by CPU. And then we will check the forwarding decision based in software. And after that, the forwarding decision will be stored. Okay, whatever CPU is taking that decision, जो भी decision switch ने लिया है, okay, whatever decision the control plane CPU is taking, that decision will be stored in the data plane. It means how switch is forwarding, how the control plane is forwarding, processing that traffic, that similar kind of processing we will copy in the fast switching cache, and we will be going to forward all the traffic with the data plane. Okay, means you can see, and the forwarding decision is made in the software. However, the forwarding decision is stored in the data plane hardware fast switching cache. And whenever next frames comes, okay, whenever like subsequent means the next frames will come, second, third, fourth, fifth packet, then we will check the hardware fast switching cache, and we will be going to process all that without interrupting the CPU. Means we will not check the CPU, and we will be forwarding the packet to the fast switching mechanism, this fast switching cache. So there are different names also of these switching. Fast caching has a different names also. Okay, on a layer 3 switch, fast switching is also called route caching. In some of the books, you are going to read route caching because we are going to cache the routes and all. Flow based switching because we are maintaining the same flow. First, we go to CPU and rest all the packets are going to copy that flow and we will be processing from the fast switching cache. And also, it is also called demand based switching. Okay, so these are just synonyms, or you can say the similar kind of names of the device. Okay, so we have now Ceph. Ceph is the papa of both switching. Okay, advanced little, obviously. So you can see here, I'm putting in the notes and these are toggles. So click here and read it. Okay. So Ceph. So Ceph is a fastest switching mode and is less CPU intensive than fast switching in process. This is the best method, and this is why the Cisco Ceph is a by default mechanism in the Cisco devices. Read this line. The switching method is the fastest switching mode and less CPU intensive, means it will take very less CPU in comparison to fast switching and process switching. So basically what happened in the Ceph, okay, so see Ceph, okay, whatever packets we are going to forward from the first packet, second, third, fourth, whatever packets, when you hit on the ingress port, inside port, inbound, okay, the packet first go to fib table. Because I told you in control plane, we have a table that is called RIB, that is called your routing table. Okay, and there is a data plane that contains already your fib table. Okay, that is called your forwarding information base. And there is another table where that is called adjacency table. So with these two table, fib and adjacency table, the device is going to forward the information. So basically, fib is your copy of routing table and your as well as what we call layer 2 ARP. Yeah, it is a copy of your ARP table. Okay, so let me add something. Okay, so the control plane CPU, if you read it here, the control plane CPU of a Ceph create two hardware tables. One is called forwarding information base and one is adjacency table. Okay, an adjacency table using layer 3 routing table as well ARP table. Okay, so basically adjacency table is a combination of your routing table and ARP table, and fib is like already a copy of your routing table. Okay, so using the routing table information and the ARP, we take all our decisions. Okay, we take all our decisions. So if I show you. Hmm. इसको घुमाना है यार फोटो को. How to rotate. Yeah. Okay, so that's the important thing now to discuss. Okay. So normally in router, we have a table called routing table. Clear everyone? Yes. In router, we have ARP table also, like which store the MAC address of the device. Okay. Like this is the MAC address of outgoing interface. Okay. So we have routing table. In routing table, what we have? That we have EIGRP route. And this is the network. This is the slash value network mask or subnet mask. This is my next stop address. And in the routing table, we also check what is my outgoing interface. Okay. So by the combination, the first we check routing table. This is my first step. Then we check the second step, that we are getting a packet. And then the packet will go to the layer 3 engine. Okay. We are checking the routing table, checking the ARP table. And by looking at this table and all, I create a cache memory that is called fast switching cache. Because I told you there are two types of switching, that is process switching, and the second is a fast switching. Process means all the packet will go to router, check the routing table, forward it. And the fast switching means there is a fast switching cache, which means we store where is 1000. We store the network address slash value from the routing table, means the address and prefix we will carry from the routing table, and MAC address we carry. Okay, to go to this next hop. Okay, what is MAC address? I have to go to ARP and check. To go to 172.16.1.2, I have to use this MAC address, right? Are you getting my point? First, I check routing table. Then I check where is 172.1.2. Then I check the MAC address. It is like router is checking routing table. Then it is checking ARP table. Then it processes the traffic. But the fast switching is going to check where is the routing entry, what is my network prefix, what is my MAC address information, and then we got the interface. All this thing we store in the fast switching cache. Okay, so if you forward all traffic with the fast switching, you go and check the fast switching technique and get all that information. We got the interface, we got the MAC address, and directly without going to check routing and ARP, I will not check this. I will only check the fast switching table. Okay, this table, and I will forward the information and forward it to the outgoing interface. Are you getting my point? Yeah. So this is just one section. ये फास्ट स्विचिंग था, ये जो भी बताया. दिस इज एग्जांपल ऑफ फास्ट स्विचिंग, नॉट सेफ. लेट मी राइट हियर. सो फास्ट स्विचिंग ऐसे हो रहा है जो अभी ये दिखाया मैंने. या अभी सेफ पे आ रहा हूं मैं. ओके, थोड़ा यार टाइम लगता है. Adjacency table and neighbor table is same. No. So that is, do not mix your OSPF concepts here. ठीक है, वो हम उसमें बात करते हैं OSPF में. Okay, so Ceph. Okay, again the same case, just little bit different. Like earlier, yeah. So you can see here again we have a routing table. We are going 10.0.0. This is my prefix. Next hop, exit interface. From the next hop, I check my MAC address. Okay, this is where I want to forward the traffic. That's ARP table. And by the combination, I create two tables. One is called fib, which is a forwarding information base, where I will check, okay, this is the network, this is the prefix, and I need to check my urgency table for this entry. Okay, so I'm checking the fib table. I got my next hop 172.16.1.2. And again, that information is also available in the routing table. But remember, routing table is in my control plane, which which is actually used by CPU, means CPU will be used, right? And in this data plane is basically by some chips like ASIC, I told you yesterday, like application software integrated circuit, or UFID, universal identifier chips. So that is Cisco hardware chips, where you have the fib information. The packet will come and check the Cisco hardware chip, and where we see, okay, 10.0.0 /8, I have to contact 172.1.2, and that is in the urgency table. We see 172.6.1.2. The next hop MAC address is this, and that MAC address we have taken from the ARP table. We got the exit interface from here. Exit interface. We know the exit egress MAC address also, that this is how I want to forward the packet. Egress MAC means where I want to forward the pack. Okay, this is my destination MAC. This is my next hop MAC. Means when my packet is here, I already know my destination also. Are you getting my point? When my packet is here, almost in between the device, the packet is not going to see, okay, now I got the point here. Now I will reconsider. If you remember process switching, first you get a packet, you open packet, you check routing table, then you again build a layer 2 information, then you forward to the destination. But here, you already know your egress MAC also, that where I want to forward the packet. Okay, can you see that? This is how, this is why, like this is most important technique, and Ceph is built by the fib table and urgency table. Okay, so if I'm taking, or if consider, if I'm giving an interview, if somebody is asking me, okay, tell me Ceph. So what should I answer? So if anybody is taking my interview, and mostly some companies ask you what is Ceph, so you can easily say that Ceph is a fast switching method, which is going to take a which is built with the fib table and urgency table. So fib is like a copy of your routing table, forwarding information base, and urgency table is a combination of your routing table and ARP table. And by the combination of fib table and urgency table, we are going to process the Ceph packets very fast. So it means, so whenever any you receive any packet which is Ceph switched packets, they will be forwarded from the they will be forwarded directly from the fib table, look the urgency table, and forward directly egress packet. Means we will not go to control plane. But if it's a Ceph punted packet, Ceph punted packets means Ceph cannot understand these packets. Okay, there are some packets which Ceph cannot process, like maybe NAT, maybe some ACL, whatever. Okay, so those will be again go to the control plane. Means all the packets, 100% traffic you cannot forward to Ceph. You can achieve almost 80-90% your traffic will go from Ceph, and remaining your control main traffic will still go from with your process switching. Okay, so what are those punted packets? Punted packets means Ceph में वो support नहीं करते. Okay, those who do not support Ceph. So maybe they use some IP header options, maybe some extra special type of packets. So if any TTL value is expiry, then router will give the TTL value expire message to the device. Okay, if it is a tunnel interface like IPsec tunnel, GRE tunnel, okay, some security kind of VPN, so they will not be processed from the Ceph. It will check routing table. So if any packet which is not supporting your encapsulation, okay, normally if it is there are some encapsulations like maybe it is dot one q, or maybe it is any other different encapsulations we have. Okay, like HDLC, PPP, WAN में use होती थी. Normally we do not use the frame relay kind of technologies nowadays. Okay. Okay, and I want to route the interface with encapsulation types. Means there are some exceptions, or maybe my packet has more MTU, because if you have a limit of 1500 on a device, but you are trying to forward more than that, so the router will forward that packet to the CPU. So CPU is going to going to divide that packet. Okay, that must be fragmented. So who will divide that packet? The CPU. Okay, that if any big packet is there, I have to divide this into multiple parts. All these type of packets will go to the as non-Ceph packets. So non-Ceph packets are Ceph punted packets. So they will be processed from the routing table and ARP table. Okay, so let's take 5 minutes break, guys. Okay. Yes, guys. Audible? Hello, hello. Yeah.
Yes, sir.
Yes, sir.
Questions?
The question is that if we have a safe partner, then why we need process switching and fast switching?
So this is like first the process switching came in the market. Okay, then fast switching, then safe. Like according to the time, they have upgraded their techniques. But you cannot do everything with the safe, right? There are some packets which need to process from the process switching. But almost most all the traffic nowadays, like when you go to Cisco devices and all it is processed with the CEF.
Dot one X traffic
In,
support होता है essentially क्या?
in which case
Dot one X traffic.
Which traffic?
Dot one X.
हाँ .1x what? CEF के साथ?
Yes, sir.
देखना पड़ेगा. You need to check .1x and CEF. Is it supported or not?
Okay.
Yeah.
So जो forwarding table से cache table generate होती है तो कितना time create
Amit, you are not audible. Check your mic.
Hello.
Yeah, I'm just getting your voice, but not clear. Repeat again.
तो forwarding table में cache table generate होती है तो table कितने time
Forwarding table you are asking?
Yes, sir. तो cache
So,
table generate होती है
हाँ.
कितने time create होता है सब time create होता है या
Guys, are you getting his voice?
No.
No.
Not clear, sir.
No, sir.
No, not yet.
Amit, go to Zoom settings and change your mic. If you are using any headphones, remove that and ask question.
Sir, what is the ideal CPU utilization in multi-layer switch?
Ideal is like 70-80 is also ideal for some companies. And some companies treat 70-80% is very high.
Yeah,
I have
and what-
seen companies, their CPU is like 90% and they are saying that's okay.
Yeah, one time it happened with us,
Mm-hmm.
and all of a sudden it came down like 60, like this.
Mm-hmm.
It took until 85 to 90.
Yeah, 80-85 also sometimes okay, because sometimes like if it is high security or something, the devices will be on very high CPU.
So there are any particular steps that we need to control?
So you just need to control like CPU just have to check that device is like not having too much packets to process. If you configure like your routing table has too many entries, so routing table is taking too much time to process. Your routing table should be small, okay? And like you should enable CEF kind of technologies. If you stop your CEF, okay, there is a command no CEF. So if you disable CEF or the fast switching techniques, so all the traffic will hit on the CPU, right? So that can be checked also. The device should forward the traffic with the help of fast switching or CEF, not all from process switching.
So it
means
means all the new devices which are coming, we need to enable CEF manually or
no. CEF is enabled by default.
enable by default?
Yeah.
Sir, I have a question regarding QoS.
Mm-hmm.
Sir, if we enable QoS in our L2 switches, it will consume memory.
So layer 2 switches, like obviously they will consume memory.
So if the traffic will not, if a traffic नहीं जा रहा, तब भी consume करेगा memory को क्या?
नहीं, फिर नहीं करेगा ना.
नहीं करेगा.
Quality of service will be implemented, and if any packet is hitting that okay, it is a quality of service packet, it is a ACL packet, then only it will be checked. You can see here. So if there is a quality of service, then it will hit on the COS ACLs, or we will be check, because in quality of service, we will check, okay, which network is prioritized, and then we check those details. But if you just configure, but there is no traffic coming from the same side, so we just check the CAM table or just cost table, but will not process any traffic.
Okay, sir.
सर ये सैफ L2 में भी अवेलेबल है क्या फीचर?
हाँ, सिस्को के लेयर 2 में होता है SF.
ओके.
Hello, sir, आवाज आ रही है अभी?
Yeah.
Sir, actually my question was that जो कैश टेबल फॉरवर्डिंग टेबल जनरेट करता है कैश, वो कितने समय के लिए लाइक वो स्टे होती है, मतलब वो ऑटोमेटिक डिस्ट्रॉय हो जाती है, वो लॉन्ग टर्म के लिए होती है, कुछ सेकंड्स के बाद?
So there is no such time, but yes, there is a ARP table, MAC address table timing, that is around 5 minutes aging time. But if it comes to routing table, ARP table, fib or urgency, there is no such time.
Sir, we can increase this time, adjust this time.
Yeah, let him complete question. Yeah, Amit.
Okay, and my the second question was that जो fib table generate होती है वो replica होती है rip table की, I mean जो copy होती है rip table की, I mean जो fib table होती है वो rip के without rip table generate नहीं हो सकती है?
Yes, fib is like a cache memory of a routing table.
So it cannot be generated without rip?
No. If you do not have entry in the routing table, fib will not be generated.
Okay, all right. Thank you.
Okay.
Sir,
Yes.
Swasti here.
Yes, Swasti.
Sir, my doubt was in Ceph, the packet first goes to fib table, but as we know that fib is present in data plane and routing table is present in control plane. So for the first packet at least, it should go to routing table, then it can come for the similar traffic to fib.
No, it is not required, because fib is also similar like routing table. Suppose you want to go to 10.1.1.1. Okay, Swasti. So we will, the device, when it receives the packet, first we check the Ceph table fib entry. And in the fib, if there is 10 network, I already got the information of my next stop directly from here. And I got my next stop, and that next stop, I already know my next stop MAC address. I know the exit interface. Even I know the destination MAC address. So this is why I will forward the table from the data plane itself. But suppose an entry, like maybe 15.00 network, okay, that is coming, and we will be checking that in the routing table, because there is no entry in the fib. Then we check in the routing table, is there any 15 network? No. So router will say there is no destination network in the table. That packet reply will be getting from the control plane, not from the fib. समझ रहे हो? अगर एंट्री नहीं है ना, if we do not have entry, we check routing tables, and if we do not have entries in the routing table, router will reply with the unknown destination message. Okay, yeah.
Yes, I got it. And one more, the ARP table is also present in the control plane, and we fetch the data from ARP table to adjacency table in data plane.
Yes, correct. So adjacency table is a combination of your routing IP. You can see there is IP. There is IP here. There is a MAC address. We got the MAC address, but we got this interface from the routing table. Can you see that? 172.1.2 exit interface GI00. But in the ARP table, there is no exit interface. The exit interface, or maybe the exit MAC address or destination MAC address also we got from the ARP table. Means combination of both routing table ARP, we make two tables, fib and adjacency table. By combination of fib and adjacency table, we use this Ceph switched packets, Cisco Express Forwarding. नाम से ही है ना, Cisco Express Forwarding, like what we use, Express Highways. Why we call Express Highways? Because they are very fast.
Okay, sir,
Sir, why can't...
Go ahead. Please go ahead.
Sir, just one. Why can't we enable these things in fast switching rather than what we learn in fast switching? if
So-
Ceph can work like this?
So it's again, I'm saying, like, this is like timely. Cisco has upgraded their technology. So earlier, everyone was like on this technology, process switching. Okay, process switching से सारा traffic forward होता था पहले. Okay, after that they have created a technology where it support fast switching cache. Then in the second fast switching, they created fib. Remember, what is fast switching cache? Only fib बना दिया इन्होंने. After that, they have created fib entry so that everyone can check the cache and forward. Now, after that, they also created an urgency table with fib. So with the combination with the fib and urgency table, now we have the latest technique, which is Ceph. Okay. So time to time, we have upgraded ourselves, right? The same way devices are also upgrading. Okay. Yeah. Yeah.
Hello, sir.
Yes, Amit.
Sir, can you open this Ceph image?
Yeah.
Yeah. Sir, can you explain me the next hop MAC address and egress MAC address? Next hop MAC address is the like the next destination, or what kind of MAC address it is? I mean, next hop MAC
So
address.
whenever you see this 0C MAC address, remember this is a Cisco MAC address. So whenever any MAC address start from 0C, it is a Cisco MAC address. And you can see next hop MAC address means the next hop MAC address is like, I got my packet on the inbound interface, and outbound interface is my next hop MAC address. And my destination MAC address is my egress MAC address. Maybe this is my computer MAC address, which is on the back. You can see na egress packet. So egress packet means going further to any device. That is your egress MAC.
Okay. All right. Got it. Thank you.
Okay.
Hello, sir. Can we view the fib table in the switch?
Fib table in the switch. We are discussing fib only. You can see layer 3 forwarding engine.
No, that the command wise. Can we see the what are the fib table?
Yeah, we'll see.
Okay.
Show
And
IP forwarding table is the command. Show IP Ceph is the command to check Ceph. Okay, I'll show you.
and any
Yes, sir.
process switching Cisco switch available or any model is available nowadays, or
We can
that's very old?
disable Ceph. We can disable Ceph and automatically it become process and fast switching. And by default, there are some packets like I told you, VPN tunnel, IPsec tunnel. So the security tunnels do not use Ceph kind of technologies. Still, my traffic is going to hit on the process switching.
But when is transferring the data first time, after that they have the cache table also, no?
But
उसके बाद तो
that is
ये-
exception. That is exception because in VPN header, we add already lot of information. VPN अगर आप पढ़ोगे ना, when you learn VPN, you add a lot of information like GRE header. GRE header itself add a lot of information. So if you keep adding lot of information in the headers or packet, the data will go very less in one packet because you are consuming lot of information for the headers like layer 2 header, IP header, TCP header. Then you are using this switching headers. Okay, layer 2 information. That's why.
सर मेरी एक रिक्वेस्ट है, अगर आप हेडर्स एक बार बता देंगे बाद में, मतलब नेक्स्ट क्लास में जैसे हेडर्स एंड फ्लैग्स वगैरह.
ठीक है.
थैंक यू.
Okay.
Sir,
I'm going to the topic back. So hold on now. Navneet, I'm recording that. Don't worry. Okay. Okay, so एक वैसी है. This is like extra information that for there are two type of Ceph also. Like if we are discussing Ceph, obviously. So there is centralized and distributing switching, and so layer 3 Ceph will be used in two type of techniques. Okay, if you check here. So layer 3 Ceph switching basically has two different locations on the device. So one is called centralized switching. Okay, one is called centralized switching and one is called distributed switching. Okay, distributed switching. So as you all know, yesterday I've given you example that one device has the line cards, all those things, right? So if I show you the diagram, centralized switching ka, okay, so this type of design or Cisco device running centralized Ceph. Okay, ये यहाँ देखते हैं. Okay, and there is distributed forwarding Ceph also. So this is just a new thing which is there in the content. Yeah, so what is centralized switching? So you can see this is a table. So this is my routing processor, like CPU can say. So in routing processor, the control device, we have routing table, fib, adjacency table. So all done with the route processor, means CPU or the complete route processing. Okay. So then we have different line cards. Okay. The GI010, GI011. Okay. So this is just an example of the device which has line cards and all. Okay. Like ऐसा कोई device जो जैसा ये वाला जो मैंने दिखाया था आपको. If you remember that yesterday device. That in one of the device you have a supervisor engine, right? So what are these? So if you see this type of design, okay, so these devices are your line cards. Okay, with line cards. So there is high chance that if one device is on the line card 1, okay, maybe this is line card 2. So maybe there is high chance that this computer A is trying to connect to, or maybe server, which is the B. So it means the computer A is transferring the packet to computer B or server. At the back end, they are also forwarding the information to each other, right? Yes or no? Are you getting my point? If computer or server is on the A and B, so we have one cable on the line card 1. This is called line cards. Okay, like consider this is like switch inside the switch. Okay, this is switch 1. This is line card 2. This is line card 3. This is line card 4. And at the back end, they are already connected to each other. Okay, the back side, they are already connected. And these are two supervisor engines which are called brain of a device. So now you consider this thing. Okay, so centralized switching kya hai? What is centralized switching? With this type, switching decisions are made on the route processor by central forwarding table. Okay, typically controlled by ASIC. ASIC is a chip used in Cisco devices. So basically, when centralized Ceph is enabled, okay, जब हमारी centralized Ceph enabled होता है, when our central Ceph is enabled, the RIB, okay, the fib basically, the fib table, okay, and the adjacency table and the routing table, okay, all these tables are performed by route processor. RP performs the Ceph forwarding. मतलब ये जितना भी processing है, all that processing will be done with the help of route processing. So you can see if I want to forward a packet from one line card, okay, अगर एक line card से दूसरे पे जाना है, if I have to forward traffic from one line card to another, I have to go to my router processor and then I have to go forward a packet to the line card 2. दिख रहा है? I have to forward in these type of devices which I shown you just now. So because we have line cards, multiple 1, 2, 3, 4, right? And this is your soup. Okay, consider this is your supervisor engine. So we have to forward the traffic to the SUP so that I can come to my line card. I will forward to another and I'll come back to line. Means, अगर वो photo हम दोबारा देखें, if I see that picture again, so what we are going to do here, that if I want to forward traffic from this side to this side, I have to forward my traffic to the supervisor. Then supervisor engine will forward the traffic to the line card too. Are you getting my point? Yes. So the brain is used here, right? This is the brain, right? So in the centralized switching mechanism, okay, what we are using here. So when centralized Ceph is enabled, the Ceph fib table, adjacency table reside in the RP. RP means route processor. Okay, in the route processor, and RP performs the Ceph forwarding. Means who is doing that Ceph? The Ceph is done with the brain of the device. Okay, that supervisor engine. So this is the example, like fib, adjacency table, Cisco, traffic is forwarded. Break down the lines if you do not understand the whole paragraph. Traffic is forwarded between LAN to a device on the enterprise network that is running central Ceph. The RP performs the Ceph forwarding. This is called centralized switching, means the device itself is doing Ceph for you. That's it's called centralized switching. Then we have distributed switching, that is called DCEF. Okay, तो ये क्या कर रहा है? Can you see that we do not have to go to the route processor? My line cards directly forwarding the traffic from line card to line card. Okay, can you see that example again? The arrows are forwarding the traffic to the route processor. Okay, so route processor pe ja raha hai. But in this, we are not forwarding to the route processor. So switching decisions can be made from direct line card to line card rather than going to the route processor. So it is like we are going to have the cache table, and that cache table will be synchronized between all through the chassis. Okay, means all the line cards. So you can see when distributed Ceph is enabled, the line card maintain identical copies of fib and adjacency table. So it means if I have routing table, fib table, adjacency table, who is controlling route processor is controlling. But what if I copy that all three tables in this line card, in this line card, in this line card? If I have all the copy, I do not have to forward the traffic to route processor, and device and the line cards can take their decisions automatically. So the DCEF, when distributed Ceph is enabled, the line cards maintain identical copies of fib and adjacency table. So it means the line card performs the express forwarding between adapters and relieving the RP of involvement in the switching process and enhancing system performance, because we are not asking route processor to give me some of his efforts to process the traffic. So basically distributed Ceph uses an inter-process communication, IPC. So can you see IPC? Okay, so inter-process communication, so that all my devices, all my fib tables, adjacency tables are on the route processor and the line cards. So this is the next generation. Now if you want to get into the proper hardware, and if you try to search Cisco DCEF, all this thing, right? Maybe like Cisco conduct a lot of events that is called Cisco Live. Okay, so these type of things, like a lot of every year Cisco conduct a Cisco Live. Okay, so Cisco Live registration is now open for Las Vegas, right? This is the date, June 4th to 8th, Las Vegas, Melbourne, Amsterdam. Every year they conduct, and the best thing, like after sometimes they put webinars on this website. You can check about the new security. Okay, I remember SD-WAN. Okay, I attended their 2016 session. In 2016, I already know about SD-WAN basics in 16 or 17, because the latest technology, what Cisco is bringing in the market after 3 years, 4 years, that they introduce in the live sessions, because they ask big companies to come on these events. They ask engineers to come on these events. Okay, and they talk about a lot of technologies about networking, Wi-Fi, okay, ACI, lot of technologies. Okay, so this is what new releases. And so you can see these are the keynotes. Okay, 2023 Amsterdam. Okay, and if I search here DCEF, I don't know if DCEF is available. Hyphen लगाना पड़ेगा शायद. Or maybe let's type DCEF. It's not going me anything. Or okay, so this is how we check about DNA, because last year they discussed about DNA. They discussed about Cisco intent-based multi-domain integration for SD-WAN and SD access. I mean, this is all their advanced things. Okay, like DevNet के बारे में है, तो DevNet के ये PPT मिल जाएगा तुम्हें यहाँ से. Okay, I think we can download it here from our. If I should be the partner, I think, to get it downloaded, or maybe some notes are publicly available also. Okay, so this is like, okay, so it is just asking me the level and all. Okay, what technologies or what things you want to know more about. Okay, you can choose about these things. And I hope you got the point, right? You can explore now. You can see I got the PDF now, direct from Cisco Live. Are you getting my point? So this is the latest things you can explore, but not right now. Hold on. Learn CCNP. Okay. Because I told you yesterday that you have, right, 7 to 8 hours a week to learn new things. So it's better to stick to the topics, because even if you learn the latest technologies, but in interviews, maybe the interviewer don't know those technologies yet. So what the use of knowing the very latest things? So this is what I check normally, because I have all the documents of Cisco Live and all. So whenever I'm free, I just randomly check their content, what is going on in the industry. Okay, that's why I'm able to give guidance to the people. People ask me, what should I do? I know where the technology is going ahead. So you just put yourself one step further than anyone in the market when you read these kind of documents. Okay. So you can see he's saying automation is the modern infrastructure, what blood is to the body. It is core. You cannot have modern infrastructure without network automation. Blood to the body, Lavdeep. Okay, so this is just an example what you should do. Okay, but yes, I hope most of you are clear with the things till now. And yeah, Ceph is used in switching and also in routing. Okay, Cisco router also have Ceph, and Cisco switches also have a Ceph. Okay, so once we have here, okay, once we know this Ceph and all, then I told you there are very uh, basic concepts. Okay, that is called hardware redundancy mechanism. In some of the devices, Cisco, like Cisco has supervisor modules. Okay, like for example here. यार मैं दिखा दूंगा सेफ केशव, डोंट वरी. सेफ की एक कमांड है, शो आईपी सेफ. ओके, आई टोल्ड यू टुडे, लाइक जैसे सपोज व्हेन आई विल बी doing EAGRP lab or OSPF lab, I'll show you the Ceph. Don't worry about Ceph यार. अभी देखना है, so right, you can check show IP Ceph. Okay, and try to check the screenshot of this. Here a Ceph table. See, like if you want to forward the default route, like already next hop is there, already you have the FA0 exit interface is there, right? Can you see that? If you want to see in detail, you can see show IPsef and the IP name. You can see all it details next top. Okay, this is, and you can also check adjacency table, show adjacency table. वही है देखो. This is safe. This is adjacency table. In adjacency table, let me add these screenshots here. Okay, so let me add it. Okay, so this is your safe, and this is your ARP. Okay, so the pixels are not good. Okay, but here it is written all your MAC address, all those things. ठीक है, दिखाऊंगा मैं इसको, मैं आपको, डोंट वरी. Okay, so hardware redundancy mechanism. So there are some special devices in the market which has multiple supervisor engine. So very old model was 4500. It is obsolete now. Then we have 6500. That is also almost obsolete. But still many companies are using. But some latest ones are 9400, 9600. So these are not Nexus devices. They are not data center devices. They are still used in enterprise networking. Okay, but the best part is that they have two supervisor engine installed like this. Okay, so what do you see here? There are two supervisor engines. Okay, so then I told you this is hardware redundancy mechanism. So like there are three types of routing. There are three types of redundancy mechanism. The first way is a route processor RPR. Okay, what is RPR? So तीन तरह के हैं. RPR क्या होता है? What is RPR? So RPR means in this mode, so by default, if your device is on RPR mode, the redundant supervisor is only partially booted and initialized. It means the second, because one is active, one is standby. The standby device is partially booted, means half boot ho rakha hai wo, already half booted, and initialized means a basic initial steps are done. So when the active module fails, when my active processor supervisor engine fails, the standby module must reload every other module. Okay, all the modules in the devices like line cards, all other modules in the switch, and then initialize all the supervisor function, and failover time is 2 to 4 minutes. It means if my active brain fails, the second brain will take around 2 to 4 minutes to come up. Clear everyone? So अगर आपका main brain खराब हो गया यहाँ पे, if your main device is gone because of some CPU high or maybe anything wrong or software bug, so the device is going to take around 2 to 4 minutes to process the traffic that is called RPR. No, you cannot modify this time because they have further improved the things, and then we have RPR plus. कौन सा? RPR plus. So in RPR plus, so in this mode, the redundant device is booted, allowing the supervisor and routing engine to initialize. Okay, no layer 2, layer 3 function are started. Just remember these functions, layer 2, layer 3 is pending, but rest everything is on. Here only half device is booted. Okay, and already like it is taking 2 to 4 minutes. But here supervision engine allowing the supervisor and routing engine to initialize. Okay, यानी ये जो दूसरा जो supervisor है fully booted है. You can see the redundant supervisor is booted. So booted means already it is booted. In the first way, this is partially booted. Can you see the difference? RPR means half reload, but just if active fails, then only I am going to reboot it completely. That's why it is taking 2 to 4 minutes. But the second RPR plus, already we have rebooted, already it is booted, but the standby module finishes initialization and it will reload all other switching module. But this device will only take 30 to 60 seconds for the failover. If your main processor, if your supervisor engine fails, within 30 to 60 seconds, the second brain will come in and become active. Clear RPR plus? Okay. And then third one is SSO, which is the super fastest way. This is called stateful switchover. Cisco ने बनाया ये सारा. अब ये वाला. So Cisco devices has SSO, so which is stateful switchover. In this, okay, this is the latest one kind of. So in this mode, the redundant supervisor is fully booted. Very good. What else? The startup and the running configuration in the device are also synchronized. Means the active brain and the backup brain both have the running configuration and startup configuration same. Layer 2 information is maintained in both supervisor. Hardware switching can continue during failover. Means everything is same. The state of this switch interface is so that links do not flap during a failover. Means the failover is just 2 to 4 seconds. 2 seconds में दूसरे brain पे shift हो जाएगा traffic. Within 2 seconds, I think only one packet will be lost. Only one packet. And your traffic will be shifted to the another backup processor, not processor, supervisor. Okay, supervisor has a RAM, processor, means this is like copy of each other. ये control plane है, okay, both are like, you can say control plane. Okay. Guys, bore तो नहीं हो रहे ना? Are you getting bored? You should not, because you are not going to revise these topics from anywhere now. This is exclusive content. Okay, so there is a Cisco non-stop forwarding. This is called NSF. एक टर्म ऊपर लिख लेते हैं. Cisco non-stop forwarding. What is this? So this is like additional add-on with, yes, in Cisco created NSF. So you can enable another redundancy feature with SSO. Okay, so if you enable SSO, because that is the latest technique for my redundant supervisor engine. Okay, तो ये क्या है? Redundancy modes हैं. Okay, what we discussed just now, these are called redundancy modes. Okay, on my devices, which are Cisco devices. Okay, which are 9400, 4500, 6500 kind of. So the first one was route processor. The time is taken 2 to 4 minutes, booted partially. Then RPR, almost done, almost booted, but we will not process layer 2 and layer 3 functions. But in in the third step SSO, it is fully booted. It is fully booted and also copy startup configuration, running configuration. And it is the best way for the failover because it is taking just 2 and 4 seconds. RPR plus is taking 30 to 60. So then we have additional features that you can enable this feature with SSO. So NSF is an add-on which can enable with SSO. So that's called Cisco non-stop forwarding. So basically what is NSF? So NSF is a interactive method that focus on quickly rebuild the RIB table. ये line पढ़ो. Quickly rebuild the rib table. So if you fail the active processor, the second supervisor has to create the routing table, right? So maybe that's why we are taking around 2 to 4 seconds here. Okay. But if you use non-stop forwarding, so it is going to help you to quickly rebuild the rib table after a supervisor switch over. मतलब हमारे routing table पे भी impact नहीं आने देगा, because instantly if you use NSF technology, NSF technique, okay, with the SSO, it works with SSO. It is going to build a rib table for a supervisor switchover. What is the benefit? The rib table, the routing table is used to generate the fib table, obviously for SF, which is downloaded to any switch module. That can perform SEF. Yeah, एक line. Okay. So that can perform SEF. So basically the rib is obviously required to make a fib table so that we can run SEF that we have already discussed, which is downloaded to any switch module that can perform SEF. Switch module means your line cards, if you remember, right? That we can have copies of my fib table, okay, all my rib table in the line cards. So in a nutshell, if you do not go deep dive, what is this NSF? So in a nutshell, Cisco NSF functions must be built into the routing protocols so that routers will need assistance and router that will provide assistance. In more simple words, NSF is enabled with multiple protocols. ये line पढ़ो. NSF is supported with BGP, EAGRP, OSPF, and ISIS protocol. So what you will do, if you know how to configure EAGRP, all this stuff. So if I show you EAGRP, NSF configuration. Okay, so what we have to do here with the NSF. If I go to this is EAGRP guide, and you can see NSF awareness, NSF operation. Okay, so you can see pre-request for EAGRP. Your network should be configured to run EAGRP. Okay, NSF aware router. You should have NSF aware router, means like 4500, 6500, or maybe any router with support EAGRP or any protocol. So NSF, what it will do? NSF is supported with BGP, EAGRP, OSPF, ISIS. Okay, so this is to help the router so that you do not actually down the neighbor. Okay, simple words. When you use this technique non-NSF, even your OSPF neighbor will not flap. Just imagine that your whole main brain goes down and shifted to the backup brain. Obviously, earlier my all OSPF neighbor was on which? पहले मेरे जितने भी OSPF or EAGRP neighbors were on this neighbor, on this supervisor. Once this device gone, automatically neighbors are up in this module. Are you getting? There is no delay because NSF technology is helping you to build the fib table, rib table with the support of NSF in the routing protocols. That routing protocols itself understand there is a switch over and I have to forward on traffic with no loss. So means whenever a user is transferring the data to internet and all, the user will never come to know, okay, there is a delay, there is a problem. The user session information is maintained. The user information is maintained. Like suppose you are going to google.com, facebook.com, your traffic, your session will not be killed because automatically the line cards continue to forward your traffic without loss. Are you getting my point? What is that best technique? Why these type of devices are used in industry? Because the companies who do not want a delay in, if one of the device fail, there is no such technology that if you have two devices, not this device, okay, अगर आपके पास ये दो device हो, okay, normally, and if your main device goes down, okay, that you will forward traffic from this side, right? But this device will give you hardware redundancy also, not just software redundancy. Okay, that your supervisor automatically going to forward the traffic from the another side. So if you compare what we discussed, this is the best image to understand all we discussed. OMG. Okay, so when you use an RPR, which is this route processor something, okay, so redundancy module, so RPR plus, so RPR kya tha? What was RPR? Processor redundancy, okay. The full form is RPR, but it's processor redundancy opposite, okay. RPR, processor redundancy. Okay, NSF is Cisco non-stop forwarding. Then we have stateful switchover. And if you see this image, now consider there are two brains. This is my active and this is my standby. Okay, so if active fails, in the case of RPR, the device will load the image, copy the software, sync the startup config, do some basic checks of hardware. But in RPR, it will not do any switching modules. All the line cards will not be reloaded. Layer 2 will not be loaded. Routing engine will not be loaded. Layer 3 protocols will not be loaded. Routing protocols will not be loaded. And the fib table will not be loaded. But if you use RPR plus, there are 2-3 things we will do extra, that we will use all switch modules reload. We will do the routing engine reload. But again, in RPR plus, we will not do layer 2, layer 3, routing protocols, fib. If you use NSSO, stateful switchover, we will do everything. iOS backup, sync, supervisor, okay, all switch modules reload, routing engine loaded, layer 2 loaded, the fib table synchronized, but till here. But if you additionally enable NSF technology, you additionally get two more things. Layer 3 protocols will be initialized, like OSPF, BGP, all those stuff. And routing protocols will be converged, because if one of the neighbor goes down, still you do not have a delay. Okay, but still fib table has to update it here. Okay, so SSO with NSF is the latest technology in the Cisco device, which will make your devices very, very, very fast. Maybe in companies, maybe in interviews, nobody will ask you, but maybe they will ask you what is SSO and NSF. Okay, so when anybody asks you, tell me what is SSO and NSF. So you can see this is a redundancy technique with the use of new technology, stateful switchover. My devices do not have to reload everything. Everything is fully ready, whether it is iOS image backup, running and startup configuration, layer 2 protocols are converged. And if we use NSF technology, layer 3 protocols will be converged also. Okay, so if you check here, Cisco ENCOR SSO NSF question. Okay, let's check. Okay, कोई question उठाते हैं, देखते हैं. Okay, so this type of question you may get in exam. Which of the following are valid statements when you configure NSF and stateful switchover on Cisco device? Support multicast routing protocol, support IPv4, HSRP is not supported, non-stop forwarding require SSO. Yes, C is the right answer. Non-stop forwarding require SSO to be configured. And I think support IPv4, IPv6 maybe. I think B and C will be right, because the rest few things we have not discussed yet. Because when we talk about HSRP or any other protocols, that will have their own theory of NSSO, SSO also. So it is saying C and D. Okay, HSRP, because HSRP is a software redundancy, NSF, SSO is a hardware redundancy. Okay, so HSRP क्यों गलत बोल रहे? Because HSRP is a protocol for your software redundancy. If one of the device fail, okay, if one of the device fail, you will automatically shift your traffic to the other side. Okay, so that's why it is saying HSRP is not supported. So I'm just giving an idea. Okay, so the HSRP is not supported with NSF SSO. Okay, because HSRP protocol, let me add this line here so that it will, you can come back and read this line anytime. So NSFC, this is how you get more knowledge that somebody is commenting, okay, HSRP is not supported, NHS. So this is why NSF does not support multicast routing. NSF, you must have SSO configured. Okay, any doubts, guys? So this is like a theory topic normally. But yes, at the back end, you can do that. You can change the what we call that redundancy type, redundancy mechanism. Okay, तो कहीं हम देखें इसको अगर Cisco high availability overview. So there is a PDF. Okay, so this is the ASR series router also support these kind of functionalities. तो यहाँ देखो ये क्या लिखा है, how to configure that. Okay, because when you get this into production network and you want to move the device, so you go to config mode. Okay, this is ASR series. Go to redundancy. Now you go and say mode SSO. दिख रहा है SSO mode is SSO stateful switchover. So this is the command. Go to config T, go to redundancy and go and configure SSO. That's it. This is how you configure. If you want to use that RPR, you go and say, I think mode RPR. If you have SSO, mode SSO. Okay. So ये एक PDF है. Let me add a guide here. Okay, link. Okay, if you use on Cisco like 4500 or 64500, okay, so you can say here SSO. Whenever you get any device, you just type the model and just see the configuration guide of that device and search for how to configure SSO in 6500 device. You can see the same commands. दिख रहा है? Yeah. Go to enable config T terminal and just type redundancy mode SSO and that's it. Now device will be on the SSO mode. And nowadays we have 9400 series. Okay, so just go and type here 9400 and you will get the 9400 data sheet or command line. Just control F, type SSO and you can see information about NSF, SSO operation, NSF. यहाँ से पढ़ते थे भाई हम तो. Not so these are the documentation. Yeah, how to configure. This is the command. Again, same commands, right, guys? Enable, show redundancy states, redundancy mode SSO. That's it. Even in the latest mode, you have the same kind of things. And you can see show redundancy states. Okay, if you have this type of device, it will show you. Okay, that show redundancy state. That redundancy mode is non-redundant because one of the mode is SSO, but redundancy state is non-redundant because one of the supervisor engine is fail. That's why. ये सब डॉक्यूमेंट्स तुम देख सकते हो जब भी तुम्हें लगे तुम्हें बहुत ज्यादा जानना है. ओके.
Hello.
Yes.
So Actually, sir, my question was from the three-tier architecture, we studied yesterday. There is a keyword regarding the fabric capacity planning. So can you tell me what is that fabric capacity planning?
Where you have read that?
It is in the official Cisco content.
Cisco fabric, what?
Fabric capacity planning. It is the topic in the syllabus and core syllabus.
I have to check this and I will confirm what is this. So maybe it is related to SD access or something.
Sir, I am audible.
Yeah, audible.
Sir, I am trying to communicate with you last 15 to 20 minutes. I don't have idea what is the problem is over in my mic.
Okay.
So I just want to know that how I can get these document which you are ready during class.
So what
Because
I'm preparing, that go and check your chat. Yesterday also I sent and now again I'm sending. Check chat. You got the link?
Yeah, right now I have got the link.
Yeah, click on that and bookmark this link. This link will be same for like there is no link every time. Okay, this link you can bookmark and all the notes will be updated on this link.
Hello, sir.
Hello, sir. Mahesh is here. Sir, there is one question on this redundancy supervisor device. If any device have a redundancy supervisor, okay, so in that case, one device will be active and one will be the standby. But the standby device will be standby till active device will be faulty or some problem is there, or there is any time duration that will be switch over by default.
No, by default, when there is a problem, then only there will be a switchover.
If problem is not there, for example, for 1 year or 2 years, the problem didn't come, so the standby will be stay standby only.
Yes.
It will not be in active mode.
Yes. Standby will be standby only.
Okay, and whatever configuration or whatever we will do on the part of the configuration and things in a one device. So the one supervisor, so that will be automatically right on the another device or for the
automatically. If you save in the supervisor engine 1, automatically it will save in the supervisor engine 2. Because when you say write command, you will see that commands are copied in both supervisor engines.
Okay.
Yeah.
Okay.
Hello, sir. Rahul
and
here, sir.
one more thing about it is about the MAC address. So this is right now I'm confused. Earlier didn't I get this question? Normally in a chassis or whatever routers or switches are there on SFP modules. Okay, SFP modules. They are always we are inserting in the NIC card. So the MAC address will be on the SFP or will be in the port of the switch?
Port of the switch.
Port of the switch.
Yes.
Okay, and if ETGB is there in that case?
Huh?
If ETGB is there, electronics SFP is there in that case also.
If
only on the port?
SFP is just a converter which will convert your fiber cable into optical signal into electrical signals. So SFP do not have a MAC address. The port, that fiber cable port where you transmitting the signals, that has a MAC address.
Okay. So SFP is always working like media connector, like.
Yeah.
Okay. Thank you.
Hello, sir. Rahul here, sir.
Yeah, Rahul.
Sir, you mentioned like RPR, it takes 2 to 4 minutes to come up and RPR plus 30 to 60 seconds. So in between any traffic or data will be passing, then it will be completely lost or how, sir?
So at that time, definitely, if it is 30 to 60 second delay or 4 to 5 minutes delay, at that time, your traffic is lost. Your company is not able to forward the traffic at that time.
That data won't be recorded, sir.
Loss हो गया ना, packets lost means if devices are not, how you will forward traffic. That's why RPR is there. You will lost data for almost 4 to 5 seconds. Then SSO is built. It is getting loaded in 2 seconds. Now, if you even do not want to flap your neighbors, OSPF and all, there is a NSF. You use NSF with routing protocols with SSO, and now you will never come to know if there is a switchover also. That how smooth it will become.
Yes. One more question, sir. From you mentioned like yesterday's class 9000 series chassis. So in 9000 chassis, there will be a placed a different model like 92, 93, 94 chassis model in that 9000 or 9293. There are separate chassis. They also.
You can check on Google that, but 9000 series, 9400 is a different device, 9200 is a single device, and 94 is a supervisor engine chassis design.
Okay,
you can see here, na? 9200 is a similar small kind of devices. 93 is more better. 94 is like with the 2 supervisor engine. 9500 is again like just 2U. 9600 is similar like 9400.
Okay, means 92, 93. These are chassis, and in chassis we can place different model or line card
Yes.
like that.
Yes.
Okay.
Yes.
Okay. Thank you, sir.
Okay, so there, see guys, see, just hold on. See, I'm going with the content. I'm going with the, so that you will be able to clear exam, right? So if there is a content, this is if this is chapter 2, obviously I have to teach, right? I can't skip. So that's why some of you will feel like maybe first chapter is easy. Maybe the second chapter is little complex in the theory. Okay. I told you, remember when I started this class, my objective from this batch, if you understand even 30-40% of the topic I'm discussing, that's okay. Because these things, even the experts in the industry, they do not understand everything here. Are you getting my point? तुम पूछ लेना जितने तुम्हें CCI मिले, ask them SSO, NSF if they are able to answer.
Correct, sir.
Are you getting my point? So it is part of our content. So whenever in the exam, if we are getting this type of question, we will be able to at least understand the question. Okay. And that's part of our content. So we are learning ENCOR. That's why it's there in the content, right? And few things if you check, this is a part of your content and all. Okay, like just one guy asked me some fabric thing. Okay, we will have a discussion on that. Maybe I'm not aware of that right now. I'm not able to recall, or maybe there is a new technology. I'm not saying I'm god of networking. Okay, I have not said that, right? So if new technology is coming, if I'm teaching the latest ENCOR module or something like that, even some technologies are like that, which we all can contribute and understand with each other, right? Don't depend on me. I will be here to give you the full guide, full guidance, almost like whatever I'm capable of. I can't go beyond my limits. I hope you understand, right? So, but yes, I'm not denying in that if you ask me any question, if I do not remember that time, or if I have to recall, at least you can ask that on your portal where the link you already have that, right? Which we can't say publicly, but you already have that doubt portal, right? This, I am sending that link. Okay, so make an account on this website, what I sent you. And after the class is also, you can have discussions on that. Okay. Yes, Pratibhan.
Sir, this SSO is concept for the only the chassis models or all the models for Cisco, which is
Only,
configured.
I think it's only for the SSO. Where other, because this technique is to for switchover only. Then
Okay,
so any device which has two brains or supervisor like ASR routers,
Oh,
maybe
okay.
Nexus, or maybe any device which has two supervisors, you can use SSO and NSF technology.
Okay. Okay.
Yeah.
Sir, if SSO is introduced nowadays, then it means we will never configure RPR and RPR plus because it is advanced
Yeah.
SSOs.
Yeah. Yeah.
And
True.
there might be some commands by using which we can know that our primary device is failed and now switchover is completed. There might be some command. How we will
Yeah.
come to know
Show
that?
redundancy is the command.
Okay. Okay.
Show redundancy or show supervisor engine. Okay, there are a lot of you can check the command guide I have linked there. Okay, so if
Okay.
during your career, if you get a chance to work on these devices, you can always come see these documents and try to check here. You can see here, suppose if I want to see the SSO or some redundancy, यहाँ पे कहीं ना कहीं होगा, देखते हैं how to create, okay, configure, yeah, BGP operation, NSF, ये तो NSF का गाइड था, ठीक है, यहाँ देख सकते हो आप. Try to just have a one read of this document very fast. You will get to know, okay, there is a command show redundancy states, okay, where you will come to know, okay, which device is up or which is active. Okay, just check it out.
Okay. Okay. Thank you, sir.
Okay.
This document is shared, Atulji?
Yeah. Link is there for PDF in the chapter 2 last.
Yeah. One more thing, like if you have the old devices, can we upgrade it to the latest technology, or like no, we have to get a new device for the new technology?
So totally depends on the model. Okay, like if it's very old, like 4500 device can support SSO, NSF kind of technologies, because this is not very new. I think SSO, NSF came in the market in 2017-18 maybe.
Okay.
Already it's 4 or 5 years old, but now the latest software what Cisco releases, 15 version, 16 version, they keep working on the bugs and keep improving the technologies day by day. So that a company who is running Cisco operating system in the latest 9400 will definitely work better than the 4500 and 6500, because these are next generation devices.
So there will be price implication also, right?
Pricing? Yeah, of course.
Price implication.
Yeah, it's going to be very costly.
And one more thing related to cabling, like for example, we have a connection coming from fiber. Okay, like around 3 to 4 kilometers of fiber, which is connected to switch through SFP. Then I have a firewall. Then I have to go into a different network. So like I have a normal copper port in the switch and firewall. So can I use the copper port, or do you advise going with the fiber only?
So if it is a distance of more than 100 meter, then obviously fiber is the only solution, no?
No. I mean, like I have a fiber connection coming to a data center, which is about 5 to 6 kilometers. Okay, in the data center, I have this switch with both SFP and copper port. And then I have a firewall which has both SFP and copper ports.
Okay.
So if I have to move this to a different network, so can I use copper like in the switch to when I'm moving my network from switch to firewall? Can I use copper?
Yeah, you can use.
If both are 1 gig, it will not make any difference, right?
No, nothing. Fiber is just helping you to forward your signals without any what we call that word, electromagnetic interference or interference, right? So when it is like more than 100 meter, your signals will drop, right? But with fiber, it works on light signals. So the starting source and the destination, there is no impact on the speed. But when we use copper, the more length of copper, the signals downgrade, okay, degrade.
It's only patching, like in the same rack, I'm just patching it. So I was just
you can do that.
If I have to use again fiber with SFP or just normal copper.
You can use both. You can use both. It will not impact anything. But yes, if you need a 10 GB speed between them, then you can have 10 GB SFP and put it on fiber cable if your ports are 10 GB. But if your fiber and copper both are 1 GB, then you can use any of them.
Okay. Thank you.
Okay. So, Suhail,
Hello.
are you there? Suhail?
Yes, I'm there.
Okay. So don't worry. See this topic, like obviously you are learning ENCOR. Little bit topics will get little advanced, but it is not mandatory for you to learn this chapter 2 right away. Okay. So maybe I have two options, whether I can make this topic in the end. But what if I'm teaching you something related to OSPF, you are reading the OSPF document and you come to know, okay, what is FIB, what is SEF, what I'm not able to understand. Are you getting my point? That's why I keep it here. Even if you understand 30% of it, I am very happy as a teacher.
Okay.
Okay, got it now?
The duration is the only issue, like, so that we have to take a lot of things at once.
So it is just 2 days now. So till 12, I think 2.5, 3 hours is not a big deal. Okay. At least we are not running boot camps, which are 8 hours a day. Yeah. Which is like very standard in US, UK market, right? People just attend 8 hours of classes. So even I have taken 8 hours of sessions also when I was taking corporate trainings. That is like not useful that because 8 hours you are learning and everything is going on top of your head. Does not make sense, right? Corporate training ली होगी ना ऑफिस में.
Yeah.
कितनी समझ आई है आज तक?
जी. It's difficult actually. Duration will become difficult.
Yeah. More than I think 2-3 hours is max for human brains. Yeah.
Sir, I have a question.
Yeah, Ramesh.
Right now I'm also doing CCNA classes. And in the CCNA classes, I think there is a switching part is doing over there. So I have to need a brush up whole CCNA, means whole CCNA topics. After that, I will get the CCNP, means whatever you are teaching. Most of the things are bouncing from my head.
So this will bounce on even if you ask any CCA guy to come and take a class also. Right.
So what do you suggest me that?
So my suggestion, so keep doing that. 1 or 2 classes will not what we call come to the conclusion that you are not able to understand. See, I am a person who teach things very deep. If I teach in a very normal way, you feel like CCNP is very easy. But what if you go to interviews, you go to exam, and then you come to know, okay, this is what I have not learned. Are you getting my point? मैं इसको CCNP को इतना easy पढ़ा सकता हूँ, तुम्हें लगेगा CCNA से भी easy है.
Okay.
ये मैं जानबूझ के डिटेल दे रहा हूँ. Okay, so I'm giving these all details intentionally so that you become like, even if you learn this topic, if you learn my ENCOR 50%, trust me, after this batch, you have more knowledge than any CCNP guy in the market.
Okay, so I have to give the additionally study on the CCNA topics. Because 8 to 10 hours I was busy in my office.
Everyone is busy. Yeah.
It's a very critical thing. But let me try to do that thing.
Who need a hike? Me or you?
Everyone wants to hike.
So you have to spend a little time, bro. We have done it. That's why we are teaching. Yeah.
Hello.
Yeah. Hello. Yeah.
Actually, it is possible to achieve this kind of technology in 3-tier architecture.
Which technology?
SSO, RPR. If we are running HSRP in our core devices, so it is possible to run SSO in there also.
So if you want to achieve this in layer 3, you just need this dabba.
No, sir, I have a core devices. I have 2 core devices, and I am running VRRP on both the devices. but I'm not running SSO. So that's why
So
I'm asking.
which devices you are using?
9460, sir.
Then you can use SSO. Just make it run SSO. So in case if one supervisor engine fails one day, automatically the standby will become your active router.
Okay.
कर सकते हो ना, चेक करो वो कौन सी स्टेट पे अभी.
सर प्रोडक्शन नेटवर्क है ना सर,
शो कमांड तो चला ही सकते हो. चला
Sir,
तो
it
देखी जाएगी.
applies on the 7000 series.
7000 series, Cisco 7000?
Yes, sir. Nexus 7000.
Yeah, you can check. They have, I think, SSO, NSF. It's there. Because that's a data center device. Data center always have SSO, NSO, all this stuff. Okay.
Okay, sir.
So you can see this is the document of Cisco 7000 series. Okay, this is SSO and switching mechanism. And mechanism, there are active supervisor and there is a backup. So you can see show module. So you can see, guys, this is how you check. There are two supervisor engines. Can you see that? Yeah.
Sir.
And there are multiple line cards where your gigaports are connected. Okay. And this is the software version. On every line card, you have a software. Okay. Like this line card, on every line card, you have a software. These are the serial numbers of line cards. Okay. So if any line card gets corrupted or anything happens, you need to give this serial number to Cisco to replace the product. What is called that to change the product? RMA?
RMA.
Yeah, RMA किया है किसी ने?
हाँ सर, किया है, बहुत किया है.
हाँ सर.
L1 engineers always do RMAs.
Sir, L2 also, sir.
L2 in some companies, in some companies.
All the level of engineers will do that.
Layer 3 भी, L3 भी करते हैं कई बार, जब उनके पास टिकट नहीं होता करने को तो RMA करते हैं. So RMA is just to replace the product. You raise a ticket to Cisco to change the product. Okay.
Hello.
That it is under warranty. I have to change it.
Hello.
हेलो
Yeah. Hello.
सर, मैं बोल रहा था कि आपका जो भी देखा मैंने राउटिंग टेबल और एआरपी टेबल, तो एआरपी टेबल का फुल फॉर्म क्या है सर?
Address Resolution Protocol.
हाँ वो तो अच्छा सर, चलिए भी कंफर्म करना था.
अच्छा भाई, तूने CCNA नहीं पढ़ा क्या?
नहीं, सीसीएनए पढ़ा है, मतलब पूरा रिवाइज चल रहा है बीच में.
अच्छा अच्छा अच्छा.
Hi sir, Jyotika this side. I just have a question.
Yeah, Jyotika.
Yeah, so it was the same as I don't know who was asking earlier कि my CCNA is also going side by side. तो like जो आपने कल पढ़ाया है, I am able to get 85 to 90% of that. So I don't know जो आपने आज पढ़ाया, was it really difficult या I am not able to get it because मेरा CCNA cleared नहीं है.
यहाँ पे कई लोग CCNP NRC कर चुके हैं, इनसे पूछो if they are able to understand 100%.
Like इसका to be honest, मेरे को 10% भी समझ में नहीं आया. Like everything was out of the box for me जब when you were explaining.
So don't worry, you have the recording of this class.
इसकी recording मेरे पास नहीं है, मेरे पास
मिलेगा. You will get this recording yesterday and today class recording. You just have to revise this again and again. Okay. So just make it 30 to 40% clear in your head. That's it.
Like ऐसा तो कुछ नहीं है ना कि if मेरा CCNA
CCNA से इसका कोई लेना देना नहीं है. वो सब काल्पनिक बातें हैं.
पूरा CCNP का, पूरा CCNP ENCOR NRC का, not only for this topic but the entire course.
In live or not? Hello.
Yes sir, you are.
सर लाइव चल रही है सर क्लास YouTube पे.
Hello.
I think sir has disconnected.
But you guys are able to hear me, right? I thought it's fine.
Yes.
Yes, we can hear you.
अरे नहीं गया यही हूँ. So I'm saying, do not worry. This topic is this is a little theoretical and it's related to Cisco hardware techniques. Even you are a CCNA, CCNP or CCI. So these topics will always going to going to be little difficult for us because this is all back end of Cisco technologies, what Cisco built it in last many years. Okay, like SSO, NSF, All these, this is just a vocabulary. This is when I started a class. I told you initially, all of you, that this is going to be little hard for all of you today, because this is all like technical stuff what Cisco has built during this last decade. So we just have to check what technology they are working. Okay, like you need to check what is process switching, fast switching, safe. Okay, just have a look on this website and this video again and again, and try to get this topic done 30-40%. And so when we will be going with further topics, we'll be keep discussing safe. We'll be keep discussing few terms again and again.
And यहाँ पे labs का, I mean in your organization, यहाँ पे labs का क्या scene रहता है कि there is no need to install anything on our own devices. हम जिसको packet tracers and everything, networking के live
Packet
labs
tracer is a
हो
small
सकता है.
software. Packet tracer is a small software you can install, right? But there are other.
What if because of some reasons I am not able to do so? So I can access it from the organization's lab.
So there is a, I have to check. Okay.
Yeah.
I think there is one. Yeah, you can do that, but we need to connect internet over there. So suppose you got a lab access, suppose some port number you'll be getting like 907 something. Okay. So when you log in with your ID in the labs, okay, so I think you just have to check. Okay, so what is our port number if you get the lab? Have you got it?
090.
No, no. Okay, whosoever is got it, right?
Yeah, okay.
So we'll
8087.
lab. Huh?
8087 port number.
Okay, whatever you got it, right? There should be a lab here inside the system. Okay, packet tracer I have to check, because I remember that lab we have added in the CCNA. Just we need to import here, and there is a lab
CCNA
where
में है, right? वो because मेरे पास CCNA की labs का access है.
हाँ है उसमें, मुझे भी याद है. So in there is a lab 8086 something. Okay, so I'm not able to log in here. Just hold on.
क्या सर इमेज का लिंक बता सकते हैं कहाँ से डाउनलोड कर सकते हैं अगर मुझे
रुको यार, रुको. So there should be some kind of packet tracer something. Yeah, packet tracer labs. Can you see that?
Yes.
So basically what we have done, there is a computer here. Okay, so automatically it is going to connect over the internet, because we are running, this is our office internet. So this is Windows machine, and the password is test123 for the Windows. Okay. This is a default password. Now you go to this Windows machine, automatically this is connected to internet, and now follow the same steps what we have explained to download a packet tracer. And just whenever you want to do some labs here in packet tracer, so you can download a packet tracer in this machine, because we have given access to all of you that this machine is going to connect over the internet. Just hold on. Hopefully we get an internet access. You go to network connections, you check if it is getting IP 10. Okay, fine. Are we getting the DNS? Yeah, DNS भी आ रहा है, तो चल क्यों नहीं रहा है? Okay, we can disable and enable it back.
सर पैकेट ट्रेसर का क्रैक मिल सकता है क्या?
पैकेट ट्रेसर का कौन सा क्रैक होता है? फ्री तो है.
सर ये EVNG के लिए इमेज मिल जाएंगी क्या? EVNG अगर मैं अपने लैपटॉप पे इंस्टॉल करता हूँ तो उसके लिए इमेजेस चाहिए.
2 मिनट.
सर हर बार
एक सेकंड तो दे दो मुझे यार.
पैकेट ट्रेसर को ऑन करने के बाद हर वक्त इंटरनेट को ऑफ करना पड़ता है.
No. You just have to create an ID. I think the internet is not working here on this machine. I will check with the support team. I think from the back end, the internet has something. So once you get the internet access here, okay, and so you can just follow the steps. Go to this website, skillsforall.com, make an account, and download the packet tracer. Okay. So this is how you download a packet tracer. You create an account on this website, Skills for All. So once you have the ID, you will be able to log in with your Gmail or something, right? Right. I already have Cisco account. So I will log in with my ID. Okay, Cisco Network Academy. There is a video I'm sharing with all of you. So packet tracer. So how to use a packet tracer 2023. Okay, sharing in the chat. Please check this and follow the step. And like there is a one very short video of 4 minutes also. You can check the second link because the earlier video is of like more than 1 hour. Okay, follow this step. Come to this computer. We will fix the internet issue. Download the packet tracer and you can do the packet tracer in here only. Okay. Got it?
Yeah. Thank you, sir.
Sir,
Hello.
But you do not require that actually, because if you have this lab access, you do not require packet tracer now, because most of the practicals we can do here. Like if there is a router, computers, these are real Windows machines. So obviously the practical will be better than packet tracer here. But yes, you can keep your packet tracer handy also for some small labs.
Okay, thank
Sir,
you.
other than packet
Hi, sir.
tracer,
Question.
GNS3
I have
or
two questions,
ENG,
sir.
which one is best, sir? Other than packet tracer?
So